Okay, so let us continue our energy efficiency seminar. So we stopped at this slide a while ago. So we're talking here of building automation system. So this is making the operations, the shutting off and running of different facilities in the building so that we can attain energy efficiency, energy reduction. No? Okay, so what is building automation system? Building automation system is building automation is the automatic centralized control of a building's air conditioning, heating, ventilation, air conditioning, elevators, plumbing, lighting, and other facility systems. So, through a computer system of the building, which is we call it the building automation system. The objectives of building automation are improve occupant comfort, efficient operation of building systems, and reduction in energy consumption and operating cost, and improve cycle utilities. Building automation is an example of a distributed control system, the computer networking of electronic devices designed to monitor and control the mechanical, security, fire and flood safety, lighting, especially emergency lights, HVAC, and humidity control, and the ventilation system of the building. BUS, Building Automation System, core functionality keeps building climate within the specified range, provides light to rooms based on occupancy and schedule in the absence of overt switches to the contrary, monitors performance and device failures in all systems, and provides malfunction alarms to building maintenance staff. A BUS should reduce building energy and maintenance costs compared to a non-controlled building. In the US, most commercial, institutional, and industrial buildings built after year 2000 include the building automation system. Many older buildings have been retrofitted with a new BUS, typically financed through energy and insurance savings, and other savings associated with preemptive maintenance and fault detection. A building controlled by a BUS is often referred to as an intelligent building or smart building, or if a residence, a smart home. Almost all multi-story green buildings are designed to accommodate a building automation system for the energy, air, water conservation characteristics. Electrical device demand response is a typical function of building automation system, as is the more sophisticated ventilation, humidity monitoring required of tight insulated buildings. Most green buildings also use as many low-power DC devices as possible, typically integrated with the power over Ethernet wiring, so by definition always accessible to a BUS through the Ethernet connectivity. Even a passive house design intended to consume no net energy whatsoever will typically require a BUS to manage heat capture, shading, venting, and scheduling device. So here is a slide showing that 40% is the expected savings when a building adopts building automation system. So it's quite a big percentage, no? 40% of the world's energy is consumed by buildings, okay? And 21% of the greenhouse gas emissions come from buildings. Okay, so it is very enticing, therefore, to adopt building automation systems for our building projects. And here are the top 10 companies that offer automation, no? Not only for buildings but also for industries. We have here the Mitsubishi Electric, Rockwell Automation, Schneider Electric, Danaher, Emerson, Siemens, ASEA, Brown Boveri, and Honeywell. Okay. Now, we proceed with lighting. With the advent of light-emitting diodes, LED lights, it has been a breakthrough in lighting because it saves a lot. No, the benefits of LED lighting includes efficiency, so you save a lot. It has a longer lifespan. It has a compact size, and it operates at a lower temperature. So the LED has been a breakthrough in lighting systems, from the original incandescent to the fluorescent, and also the high intensity discharge lighting fixtures. Here is a comparison of the consumption among the LED, a compact fluorescent lamp, halogen lamp, and the incandescent lamp. So here, annual cost of operation per bulb. So this one has a cost only of $1.19, and this one is $1.75, and this one is $5.05 and $7.01. So as compared to the incandescent bulb, it's about 7 times, roughly 7 times, or the incandescent lamp has much more cost in operation, by 7 times. But take note, the CFL has slight, but take note here, the wattage are this one has a lower wattage, and this one has a I mean lumens per watt. So the efficiency of the LED bulb is much higher. Okay, so it's a big breakthrough. Even other aspects have so many advantages also. Okay, so that's the advantages of the LED bulb. Now we go to solar. This slide shows us a solar rooftop, now very popular in the world. Of course, the cost has been quite high at the start of 2009, when the Renewable Energy Act was enacted, in 2008. But since then, the cost has gone down gradually and surely. So here is a setup that shows a grid tie. A grid tie meaning to say the energy that is generated from the solar panel through the inverter here, grid tie inverter, mixes with the energy coming from the utility. Okay, and it is supplied to your loads, lights, outlets, appliances. Okay, so in other words, this kind of setup reduces the consumption from the distribution utility. Okay, so and any excess that is not consumed by the appliances during daytime can also be exported to the grid or to the utility. So you just need to have a net metering arrangement with the utility company, so that the export energy will be deducted from the consumption of the house. Okay, now the good news is the return on investment is about less than 2 years now. So that means that the cost of panel and the inverter are gradually coming down. Okay, so here is this is also a microgrid tie, a grid tie system, which shows us a very small inverter. Okay, so here is the solar panel at the rooftop, and then you have a small grid tie inverter. Usually they are matched, 300 watts here, and then also this one is 300 watts. So assuming that you have bright sunshine, so you'll generate electricity equivalent to 300 watts. Then the energy coming from the utility or Meralco will also mix with that and could be consumed by your appliances, electric fans, TVs, refs, charging outlets, and so on and so forth. No, okay. So this kind of system already is the cheapest microgrid tie. In less than 15,000 you can already adopt this kind of system, and this one is for those who have limited budgets, but in the future can provide for more, so they can duplicate this or triplicate it or quadruplicate this, so that it would gradually expand your rooftop system. Okay, so here is the big picture of the solar, no? Okay, so we show here an oval line, which indicates the grid. Okay, the small rectangles here inside the oval egg are commercial loads, institutional loads, industrial loads, government loads, residential loads. And here around are circles which represents power generation. Let's start here. Bunker oil power plants, okay, or thermal plants. This one is geothermal power plants like the Makiling, Banahaw, and of course the Tiwi and the Tongonan. Here we have the gas-fired power plants. Today we have this in Batangas, the one coming from Malampaya, and you have there so many power plants there, no? And then the coal-fired power plants. This is the biggest contributor to our present grid, something like about above 40%, maybe 40 to 43%. Hydroelectric. So we have plenty of this. We have like for example, you have Magat hydroelectric, Pantabangan hydroelectric, you have Angat hydroelectric, Binga, Amboklao, you have the Calayan pump storage in Laguna, and what else? The San Roque Dam, and many others, no? In let me just pull this down. In Mindanao, we have the Maria Cristina Agus projects and the Maramag. Okay, and then we also have mini hydros that are now scattered all over the country. Now here we have the wind power plants. This is started many years ago in Ilocos, in Bangi, and it has been expanded already. Now you already have this in Tanay, also in Katiklan, and in Guimaras. Here is the solar farms. So now we have so many of these also. So by Solar Philippines, we have there in Calatagan, Batangas, and in Tarlac, and there are so many of also in Negros Island. You have there the Sacasol, San Carlos, and the Cadiz Solar, and some others in Central Luzon and some other parts of the country. And now here, of course, here other power plants. No? Here I indicated here a grouping of residential with solar rooftops. So you would see all the other power plants would be injecting power to the grid there. So the arrow indicates the injection of power to the grid for the consumer here. Now those who will have the residential rooftop will also inject power to the grid during daytime, but at night time they will receive energy from the grid if they use a grid tie system. So here is a system that is I think very much recommended for the country to grow those that will have these solar rooftops. Okay, but what would be the best to use? Okay, here is a slide that indicates destruction caused by typhoons, no, elsewhere. Could be in Eastern Visayas or Eastern Mindanao, or in Cagayan Valley or elsewhere, no? So here our suggestion is for those areas we suggest that the use of grid system, no, of grid solar system or hybrid of grid system, because when there are calamities, a grid tie would be isolated from the grid, so rendering no power to the homes that has solar. While if you have a hybrid of grid or an off-grid system with batteries, then you can still take advantage of the power. Chances are your solar will not be isolated from the grid. So here is a simple off-grid system, 12 volts DC panel, and you have 220 volts inverter power, no? So solar panel, charge controller, battery, inverter. Okay, and here is the output of the inverter for your lights. Can also be power electric fan or TV, and refrigeration. Now this one, because of the cost of the battery, has a longer ROI than the grid tie. If the grid tie has less than 2 years payback or return on investment, and off-grid, because of the cost of the battery, has a longer ROI. But of course, this one would provide for stable power even if there are calamities like earthquakes or typhoons, or even eruption, no? Just recently we had eruption in Taal, so the power there of those who have grid tie were isolated, rendering it useless. But if you have this off-grid with a battery, then you can still use or utilize the power from the sun. So here we have a setup showing of course a hybrid off-grid system with storage battery. Now this inverter is a smart type of inverter which can prioritize the energy coming from your solar panels, no, over the power that is stored in the batteries. And the last priority is the power from the utility. So in other words, in the wee hours of the morning, when say for example the energy stored in the battery is already depleted to almost 20%, then your inverter will automatically transfer power to the utility. Okay, so but if the batteries have adequate energy to reach up to 6 or 6:30 in the morning when the sun is again shining, then this inverter will not transfer power to the utility, and therefore will just be consuming energy that is generated from the sun and is stored in the batteries. Okay, now there is a correct way of installing panels. This typical installation elsewhere in Quezon City is wrong because this side is facing north, no? So we have to be very careful when installing panels. We have to install it facing south. We are in the Philippines. We are at the north side of the equator, so your panels should be slanted facing the south here, and there is the north. So it must be slanted like that, not this way, not facing the north but facing the south. Okay, so here Metro Manila, Bulacan, Bataan, Pampanga, Zambales, Pangasinan, Nueva Ecija, Aurora, Rizal, Cavite, Laguna, Batangas, Quezon, Pulilio. Within these areas, my suggestion is about 10 to 12 degrees so that you'll be able to optimize generation from solar. Here is a map of the country where we indicate the different latitudes. So if you are in Metro or in Pampanga, that's 15 degrees times 0.87. That's the recommended multiplier, 0.87, that one. So roughly it will be about 10 to 12 degrees roughly. If you are somewhere in Cebu, Bohol, Negros Island, and even Leyte, where the latitude is 10 degrees, so times 0.87, something like 7 to 8 degrees or 9 degrees at the most, no? Okay, but if you are somewhere in Tawi-Tawi here, that's 5 degrees, so your island must be about 4 degrees. Okay, if you're in Davao, maybe about 7 degrees, so something like 6 degrees. Okay, 6 degrees, 5 to 6 degrees. If you are in the Batanes, now the latitude there is about 21 or 22, so your slant should be about 18 degrees. Okay, 18, 17, 18. Okay, so that's it should be the way it is. Here is the explanation, by the way. Now here is the orbit of the Earth around the Sun. So this one is the Sun, and that is the Earth. So the Earth rotates like that. So at another angle, you would see the Sun here and the Earth is here. Of course, the Sun is very far away from the Earth. At this point in time, it is summer months in the country. The Earth is going to here. This is the peak point of summer. See, it is the closest. The Earth is closest to the Sun. So that is usually the months of March, April, and May. The Earth is moving closest to the Sun. The Sun is almost directly above us. So there. So if this is about the Philippines, no, where the Philippines is. This is the equator. Okay, and the Sun is there. You will notice that a house here, or the Sun will be exactly just above the house, vertically above the house, if you are here. So that explains why during these months it is the hottest, no, and it is the closest at which it is. So if you mounted it facing south for 10 degrees, then it will be fine. It will be fine. Now the next slide, take note, is different. The Earth is at this side, no, opposite. That was the summer time, and this is the opposite of the summer, which is the months of September, October, November. Okay, and it is also close. I mean, the Earth is also close to the Sun, but take note, the Philippines is there, north of the equator. So still, for the Philippines, it is a little farther as compared to the distance here. Here, the distance from the Sun to the Philippines is closest as compared to here. Okay, but take note, your house is here above the equator. Here's the equator. So mounting it facing south is still perfect. Okay, still perfect. Okay, here we have some more tips for a more efficient installation of solar systems. Use MPPTs in lieu of pulse width modulated solar charge controllers. So MPPTs are more efficient than the PWMs. Okay. Second, use inverters or MPPTs with higher input voltage range. Example, 580 volts DC maximum range in lieu of 120 volts maximum DC voltage range. So the higher voltage range in the string has a lower current and henceforth lower line losses. Here, other tips. Use higher DC voltage setup for your battery storage if you have an off-grid. Say instead of 12, better it is 24. Instead of 24, better if it is 48 or 36. Or if you have a 60, it's also good. Okay, opt to use on-grid or grid tie or a hybrid of grid in lieu of the totally off-grid system. In a grid tie system, any excess energy not used by the host, by the house, flows to the distribution utility or to Meralco or to the grid, and therefore it can be used by others. In the hybrid of grid system, the cheaper energy in the wee hours of the morning may be used to charge depleted batteries. In totally off-grid system, the excess energy when the batteries are full are wasted. Okay? And here is good news. Our new PEC of 2017 already allows higher voltages, no? Because in the old PEC 2009 edition of the Philippine Electrical Code, it only limits up to 50 volts DC. Now, the code allows up to 600 volts. And in farms, solar farms, it is even higher. Yeah. This is a picture of that page there in the PEC, which indicates this high voltage DC. Of course, because of this high voltage, there is now a need to install rapid shutdown mechanism. This has been required in the National Electrical Code because there was a fire incident in America, and it happened in a rooftop where there is solar panels, no, and they have difficulty putting off the fire because of the high voltage electricity produced by the solar rooftops. Okay, so rapid shutdown devices are needed to be installed to protect firefighters. Okay, we highly recommend the use of electric vehicles so that instead of using gasoline to run your vehicles, you use electricity from the utility, from Meralco or from the electric cooperatives. Of course, the electricity from the grid provides for a much cheaper energy to run your transportation or your mobility. And here we are showing you service vehicles of ours. Here we have an old FX provided with a solar panel, and it also has a solar battery inside, and also a big inverter, 4 kilowatts, which can power up small power tools. So this vehicle have already reached as far as Davao, Cagayan de Oro, Cebu, Iloilo, and even Eastern Visayas and parts of Luzon to do some servicing work. So you can also do this. Of course, it has its own automotive battery here. Okay, similarly with this Innova vehicle, also it provide there is a panel here, and there is a 1 kilowatt inverter. It has its own solar battery and also charge controller. Any excess energy coming from the solar can also be charged, can also be saved in the automotive battery. Okay, so it also reduces the heat coming from outside. It reduces the cooling load of the air conditioner of the system, and also it reduces consumption of the gasoline or diesel engine. Okay, we also suggest to provide solar panels on top of this mass transit system. This is MRT3 in EDSA, LRT1 in Taft Avenue, and LRT2 along Aurora Boulevard. So if the government can install solar panels on top of the alignment in the stations and in top of the alignment, the energy that could be generated will reduce the consumption operating cost of this mass transit system. And this reduction in the energy input from the utility can be used to bring down the fare. And by bringing down the fare, you can have money to improve the operation of the system.